3.5 limits at infinity or horizontal asymptotes. The definition of a horizontal asymptote is the limit as x approaches positive or negative infinity. It's basically saying what is happening to your graph as x approaches infinity. So I'm just making this question up, obviously. What's happening way out here as x is way, way out here? What number does it approach? Okay. A couple of things we need to be able to do before then is if you're dividing a constant by infinity, that is always 0. Infinity is a very large number, or infinity is very large. Any constant term divided by a very, very large number and basically approaches 0. If you have infinity divided by some constant, that will equal infinity because the constant's almost irrelevant. And this one, any constant divided by 0, that's sort of like a vertical asymptote. You will get, it goes to positive infinity. So for the first one here, limit as x goes to infinity. Well, I can just literally plug that in. Infinity squared is just infinity. So I end up with 5 minus 2 over infinity. That is any constant divided by infinity equals 0. So it's 5 minus 0. So the horizontal asymptote where the limit is 0. Okay. Now, they get a little trickier than that. Limit as x goes to infinity of 2x minus 1 over x plus 1. So here is the proper math way to do it, and then we'll talk about what we did in math 12. So you look for the highest exponent, all right, on your variable. In this case, it's 1. What you do is you multiply top and bottom by the reciprocal of that. So in this case, 1 over x times 2x minus 1. And you have to do top and bottom because then you're really just multiplying by 1. This gets multiplied into there and this into there, and you end up with this. You get 2 minus 1 over x over 1 plus 1 over x. All right. These are this up here, constant divided by infinity, because when you plug infinity in, you end up with 2 minus 1 over infinity, 1 plus 1 over infinity. So those go to 0, and you're left with 2 over 1, or just 2. Which, if you remember back to math 12, when you were learning rational expressions, rational functions, we talked about horizontal asymptotes. I told you the 4 rules you had to remember, or 3 rules you had to remember. If the degree of the numerator and the denominator are the same, in this case 1, you just look at the leading coefficients. All right. Well, this is why. All right. That's a cheater rule. It's a good way to check your answer. So if you look at the next one here, which actually make that a 3 or a 2, sorry. If I look at that, I'm like, okay, the degrees are the same. I know the answer should be 5/3, but you're going to have to be able to show that on a test. So we multiply top and bottom by 1 over x squared. Then you multiply that in, and I will end up with the limit as x goes to infinity of 5 plus 2x over x squared plus 1 over x squared over you would simplify these, that would cancel, and that would become 1. Put the infinity in, you get 5 plus 2 over infinity plus 1 over infinity squared over 3 plus 1 over infinity squared. Okay, that goes to 0, that goes to 0, and that goes to 0. You're left with 5 over 3, which you could have checked because the degrees are the same right at the beginning. Okay, so it's a test. Now, if you get trig stuff, Can't do that. So trick stuff, you got to think about it. All right, infinity, I can just plug this right in. So I'm going to get 1 over infinity. What is 1 over infinity? Well, that is any constant divided by infinity is 0. So I get cos of 0. What is cosine of 0? It is 1. The horizontal asymptote of this graph is 1. And if you look at this graph, it looks like this. Oscillates near the center, but it has a horizontal asymptote at positive 1. Same with this one, e to the x. Put in infinity, I get e to the 1 over infinity. Any constant divided by infinity is 0. E to the 0, any number to the 0 power is 1 as well. All right. Excuse me. Now let's do one last example. And then, whoa. Ignore all that, people. Sorry. Okay. One last example. Number 6. We will do the limit as x goes to infinity of 2x cubed plus 1 over 3x squared plus 1. Okay. So the highest exponent is 3. So I put that, I multiply top and bottom by the reciprocal of that. 3x squared plus 1, which gives me 2 plus 1 over x cubed over 3 over x plus 1 over x cubed. Okay. Now, if you plug in infinity here, what do you get? You get 2, that goes to 0, that goes to 0, that goes to 0. You end up with 2 over 0. Anything divided by 0 is infinity. So this has no horizontal asymptote. This has what's called a slant asymptote, which we will learn on Wednesday. Okay? So, when you're trying to figure out your horizontal asymptotes, look to see what your highest degree is. Take the reciprocal of that, 1 over x in this case, or 1 over x squared, multiply top and bottom by all of that. Everything will cancel, and then simplify and plug in infinity. You can always check your answer using your rules from Math 12 for rational expressions. The degrees are the same, so you know the answer has to be the leading coefficient, which it was, 5 over 3. Okay, here's your practice questions, and then on Wednesday we will do slant asymptotes. So, sorry about this. I don't know why this computer is doing this. There we go. Page 202, 1 to 5, 13, 15, and 103. All right, enjoy.